Hello, this is our final project presentation. Our project titled Implementation Social Geo Algorithm in C++ and a verified algorithm with larger data set. And our team members include Juechen Liu, Jingcheng Xu, and Xia. First, let me introduce the research paper we selected. So basically, the research paper we chose is titled Social Network Routing Protocols in Delay-Tolerant Networks, published last year on IEEE conference. This paper actually introduced a new routing algorithm for delay-tolerant networks based on the social network idea, and they also claim that they developed a very efficient routing protocol. So for our project, the basic idea is we try since the original project was implemented in Java and the simulation was done in the one simulator. Our project, the first task is to re-implement the social geo algorithms in C++ and try to integrate our functions into the NS3 simulator. The reason why we want to do this is because NS3 simulator actually can produce a more real environment, which can allow us to evaluate the algorithm, how it will perform in the real network situation. And the second part of our project is we are trying to utilizing a larger data set compared with the author used in the paper to verify the conclusion the author draw in the paper. With that, first I'm going to give you just a really short introduction, since we already talk a lot about the introductions in our midterm check. Basically, this research is related to the delay-tolerant networks, and the reason why delay-tolerant networks is very interesting and people focus research on this is because this type of network is a computer architecture and a protocol still designed to solve the data transmission in networks lacking continuous connectivity. And in today's technology, cell phones, mobile devices are quite popular. So all these type of devices are connected to the network, which is lack of continuous connectivity. So basically, try to set up a efficient routing algorithms for delay tolerant networks is kind of like a great benefit for people to use their mobile devices. And the reason why we chose this social geo paper is because this paper is very interesting because the algorithm they developed is based on the social relationships, and they use the data integrated with the social networks such as Facebook, Instagram. This is kind of like a really interdisciplinary research which combined the social network data with the routing algorithms to design a new type of routing protocols for the DTNS. This is something that is kind of like a very interesting and what we really want to focus on. So in our previous presentation, we introduced that basically we have three ways to obtain the data. One is to use the already available data set that are public, and the second way is we can collect the data from the online social networks, such as we can collect data from Facebook, Instagram, or Twitter by using some geocode API. And the third way is we can actually using the random walk algorithms to generate the data set to simulate the human behavior, human movement behavior. In our current project, we actually utilizing actually finally we decided to use the random walk algorithm to generate the data set by ourselves, because this is more easy and easy to control and easy to integrate into the simulation. In the research paper, actually, they defined the two matrices. One is encounter probability. Basically, that means if the two nodes get close enough in a range, the data transmission can happen. Another matrix they defined is the encounter count. Basically, it's just two nodes meet each other on the way. They can transmit the data. In our project, we actually simplified this model into a more easy and more easy to handle ways. So basically, what we do is we simplify the matrix into just an n times n grade to represent the map, and which can show here. Basically, the map looks like a n times n grade. And each grade unit here is represent a 10 times 10 meters area. So if we have a 50 times 50 grade, which basically represent a map with 500 meters times 500 meter, which is basically 250 K square meter area. The reason why we use this way is because it's kind of like combine the previous two matrices into one, since what we define is if the two nodes actually located into a same grade, they can transmit the data. Basically, we're just considering if the two nodes actually in a 10 times 10 times 10, which is 100 square meter area, they can transmit the data. So basically, it just combined the encounter count and the encounter probability together. And in our simplified data model, actually, we can easily handle the map. We can easily vary the size of the map, and we can easily integrate different numbers of nodes into the map. So so in our simulation, we initialize the node with a start position and a destination with coordinates. For example, shown here in this grade, we initialize a node which the start position represented by the right position with the coordinates equals to 0, 0, and the blue grade actually represent the initialized destination. And use the random walk, we can generate a random pathway represented by the yellow color from the initial position to the destination, and we can easily record all the coordinates along the way in order for simulation. And for our project, we actually create a series of grades such like this with different size from 50 times 50 to 500 times 500. And the total nodes number we actually vary from the 20 to 500. The reason why we vary the size is because first we are trying to reproduce the results the author claimed. In this way, we can confirm that our simplified data model actually works. And later on, we can easily claim our conclusion for the large data set. So basically, we can compare to the original conclusion drawn by the author. For the algorithm, we just directly use the algorithm published in the paper, and we develop this flow chart so that we can easily follow how the algorithm works. And here is just some conclusion draw from the original paper. And what I want you to focus on is actually the third conclusion showing the figure 4. Actually, the author claimed that with the encounter count, basically is utilized the algorithm. Actually, the delivery probability increased by 7% and the latency decreased by 25%. Basically, the author claimed that based on this result that the algorithm is more efficient. And another result is basically they compared their protocols with other protocols to show that actually this algorithm is very efficient. So this is just some background information of our project, and our teammates Juechen Liu gonna present you the detail of our simulation and the data we obtained from the simulation. That's it, and I will Juechen Liu will continue this presentation.